So for today's video, we will talk about permutation. But before that, let's have first an activity. So let's start. Okay, so let's assume that we have here 3 cards. We have Jack, Queen, and King. Okay, so first, get any 2 cards. So for example, we have Jack and Queen. First, arrange the cards using one piece at a time. So let us list all the possible arrangements. So we have Jack and Queen. How many possible arrangements are there? Okay, so we have 2 possible arrangements. Next, arrange the cards both pieces at a time. So let us list all the possible arrangements. Okay, so we have JQ and QJ. Okay, so how many possible arrangements again? Okay, so we have 2 possible arrangements. Next, get any 3 cards. So we have Jack, Queen, and King. So arrange the cards using one piece at a time. We have Jack, Queen, and King. How many possible arrangements again? So we have 3 possible arrangements. Next, arrange the cards using 2 pieces at a time. So we have JQ, JK, QJ, QK, KQ, and KJ. So there are 6 possible arrangements. Next, arrange the cards using 3 pieces at a time. So let us list all the possible arrangements. So there are 6 possible arrangements. So let's have another example. Suppose you secured your bike using a combination lock. Later, you realize that you forgot the 4-digit code. You only remember that the code contains the digits 1, 3, 4, and 7. So let us list all the possible arrangements. Okay, so how many possible arrangements are there? Or how many possible codes are there? So there are 24 possible codes. So what do you call these arrangements? Yes, we called it permutation. But what is permutation? Permutation refers to the different possible arrangement of a set of objects. The permutation of n objects taken R at a time is denoted as P and R, where n is the total number of objects and R is the number of objects taken at a time. Note that the value of our n must be always greater than or equal to R. If the permutation of n objects taken R at a time is given, then we will use this formula. Permutation of n objects taken R at a time is equal to n factorial over n minus R factorial, where n is greater than or equal to R. If the permutation of n objects taken all at a time is given in the problem, then we will use this formula. Permutation of n objects taken R at a time is equal to n factorial. So for example, there are 3 persons named Alex, Bob, and Mark. In how many ways could these 3 people line up? So first, let us list all the given in the problem. So the value for our n is 3, and the value for our r is 3. So we will use the formula permutation of n objects taken R at a time is equal to n factorial. Substitute the value of our n and r to our formula. Permutation of 3 objects taken 3 at a time is equal to 3 factorial. So when we say factorial, it means multiplying the value of n to its positive decreasing value. So it goes like this. So n times n minus 1 times n minus 2. Permutation of 3 objects taken 3 at a time is equal to 3 times 2 times 1. So permutation of 3 objects taken 3 at a time is equal to 3 times 2 times 1 is 6. So there are 6 ways. So another example. Suppose we have 4 different potted plants and we wish to arrange 3 of them in a row. In how many ways can this be done? Okay. So first, let us list all the given. Our N is 4 and our R is 3. So the formula, we have permutation of n objects taken R at a time is equal to n factorial over n minus r factorial. Substitute all the given to the formula. So we have permutation of the value of our n is 4 and the value of our r is 3. So permutation of 4 objects taken 3 at a time is equal to the value of our n is 4. So 4 factorial over 4 minus 3 factorial. So permutation of 4 objects taken 3 at a time is equal to 4 factorial. We have 4 times 3 times 2 times 1. We have 24 over 4 minus 3 is 1. So 1 factorial. 1 factorial is equal to 1. Permutation of 4 objects taken 3 at a time is equal to 24 divided by 1 is 24. So there are 24 ways in arranging the 4 different potted plants 3 at a time. Okay, so another example. In how many ways can you place 9 different books on a shelf if there is a space enough for only 5 books? So let us list all the given. So the value for our n is 9 and the value for our r is 5. So permutation of n objects taken r at a time is equal to n factorial over n minus r factorial. So substitute all the given. So we have permutation of 9 objects taken 5 at a time is equal to 9 factorial over 9 minus r factorial. Permutation of 9 objects taken 5 at a time is equal to 9 factorial is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 9 minus 5 is 4. So 4 factorial. 4 factorial is 4 times 3 times 2 times 1. Okay, so permutation of 9 objects taken 5 at a time is equal to, so 9 factorial is 362,880 over 4 factorial, 24. So permutation of 9 objects taken 5 is equal to 362,880 divided by 24 is equal to 15,120. So there are 15,120 ways in placing the 9 different books on a shelf if there is space for only 5 books. Okay, so let's go now to distinguishable and circular permutation. Notice that in the previous examples, the objects to be arranged are all distinct. Suppose some of the objects to be arranged are not distinct, that some are identical. So, let's consider this example. Find the number of permutations of the letters of the word statistics. So, there are 10 letters of the word, right? So, initially, suppose these letters are distinct. Then, the number of permutation is permutation of 10 objects taken 10 at a time is equal to 10 factorial. However, we have to take consideration that there are 3 S are alike, 3 T's are alike, and 2 I is also alike. So this can lead to another rule. So we called it distinguishable permutation. So when we say distinguishable permutation, it refers to the permutation of a set of objects where some of them are alike. the numbers of distinguishable permutation of n objects where p are alike, q are alike, and so on. So the formula for distinguishable permutations is permutation of n objects taken r at a time is equal to n factorial over p factorial times q factorial times r factorial. Okay, so again, in the word statistics, we have 10 letters. So let us list all the given. So for our n, we have 10. So the value for our p is 3 for our s because there are 3 s. And the value for our q is 3 for our t. And the value for our r is 2 for our I. So our formula is permutation of n objects taken r at a time is equal to n factorial over p factorial, q factorial, r factorial. So permutation is equal to the value of our n is 10. So 10 factorial over p, the value for our p is 3. So 3 factorial times 3 factorial times 2 factorial. 10 factorial over 3 factorial times 3 factorial times 2 factorial is equal to 50,400. So our P now is equal to 50,400 permutations. Okay, so let's have another example. How many possible permutations are there in the letters of the word Philippines? Okay, so first, let us count how many letters. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 letters. Let us list all the given. So our N is 11. So for our P is 3. For there are 3 P. So 1, 2, and 3. So for our Q, we have I. So we have 3 I. So 1, 2, and 3. So substitute all the given. We have permutation of n objects taken r at a time is equal to n factorial over p factorial, q factorial, r factorial. So our p is equal to n factorial is 11. So 11 factorial over 3 factorial times 3 factorial. So 11 factorial over 3 factorial times 3 factorial. So you can just solve it in the calculator. We can get 1,108,800. So our P now is 1,108,800 permutations. For now, let's talk about arrangements in the circle. So we call circular permutation. So when we say circular permutation, it refers to the different possible arrangements of objects in a circle. The number of permutation P of n objects around a circle is given by P is equal to n minus 1 factorial. So for example, in how many ways can 4 people be seated around a circular table? The value of our n is 4. So substitute to our formula. P is equal to n minus 1 factorial. So P is equal to, the value of our n is 4. So 4 minus 1 factorial. So P now is, 4 minus 1 is 3. So 3 factorial. So P is equal to 3 factorial. We have 3 times 2 times 1. So P now is 6. So there are 6 possible ways could the 4 people be seated around a circular table. Okay, so let's have another example. Find the number of different ways that a family of 6 can be seated around a circular table with 6 chairs. So the given is 6. So permutation is equal to n minus 1 factorial. Substitute the value of our n to our formula. So permutation is equal to the value of our n is 6. So 6 minus 1 factorial. P is equal to 6 minus 1 is 5 factorial. So 5 factorial is 5 times 4 times 3 times 2 times 1. So 5 factorial is equal to 120. So there are 120 possible ways could a family of 6 can be seated around a circular table. So that's all for today's video, guys, and I hope you have learned from our discussion. Thank you for watching!